Good morning. So today's lecture we will continue on Fourier series. So today is Wednesday. The reading is page 197 to 201. Then on Friday, the reading is from page 201 until 212. Next week, Monday, the readings are page 216 to 218. Then in April 3rd, Wednesday, it will be exam to return and answers. So the TA will take care of that lecture. So Friday, the readings are page 216, 218, and it will be the due date for homework number 12. Keep in mind, in Wednesday lecture, it will not be recorded. So it will not be something which we just check with this and go through the answers. Okay, any questions? Okay. Last lecture, we started that example about the sawtooth, and we need to find the Fourier series for that. In summary, Fourier series, any periodic signal can be converted into a sum of infinites, sine or cosine. So we need to find the sawtooth. To find the sawtooth, this is the general expression, A naught plus the sum of A sub k cosine k omega t plus b k sine k omega t. So let's find, first thing we've calculated omega, which is omega equals to 2 pi times f, or 2 pi over the period t. So the period here is t. Then we rewrote the x of t in times of substituting omega naught by 2 pi over t. So this is the overall expression. X of t equal a naught plus the sum, ak, bk, etc. So k is from 1 up to infinity. It's infinite series. Then t is the period. In this question, t is not given as symbol t. Then just keep it as st. The only unknown things, we have 3 unknowns. These 3 unknowns are a naught, ak, bk. So the question is how to calculate these 3 unknowns. We already know the formulas for each one by doing some integration. So A naught, which is the average value, which is 1 over t, the integral from 0 to t. So what's x of t? Go to this, look at the overall period. The overall period, it will be as linear function. So linear equation, which is something like ramp. So the slope here will be a minus 0 over t minus 0, which will be weighted a over t. Then x of t will be a over t, which is a over period of t times t as time. This is x of t. Then substitute it there. Then do the integration. Then the integration we see is to be a over 2. This is a0. Then the next thing is to calculate ak, then after that bk. So each one again has its own formula. A sub k equal 2 over t, then integral from 0 to t, x of t cosine k omega naught t dt. We've done this actually already in my last lecture, but here just a quick reminder. Then it will be 2 over 2, the integral from 0 to t, a over t, t cosine k omega naught t. Now, we have, by moving t, a over t, since it's constants, move them to the other side, then this yields to be the integration. Let's forget about t, 2a over t squared. Let's look at this integral. So this calculating this integral is complicated, it's not easy, it's not straightforward. So we can solve it by using integration by parts. Integration by parts, this is from calculus 2, and I told you last lecture, please try to review integration by parts. So we were going to assume t as u, and cosine k omega naught t dt as dv. So the integration by parts, basically, whenever you have u, find its derivative will be du by dt. Then when you have dv, find the integral. It will be 1 over k omega naught sine k omega naught t. Then the famous formula for the integration by parts, which is the integration of u dv will be uv minus the integral uv vd. So as a result, a sub k will be the constant 2a over t squared, then uv minus the integral of vd. But keep in mind, don't forget to put the integral constant from 0 to t. Then when it is uv, don't forget to make the period from 0 up to t. Now let's substitute v and u. So u is actually t. V is 1 over k omega naught sine k omega naught t. Then the integration of v again 1 over k omega naught sine k omega naught t. Then du, which is dt, because we know there du is dt. Then we need to do the next thing, which is we need to find this value. This is just a math calculus too. So don't forget the constants. 2a over t squared is everything multiplied by this constant. Then let's substitute. So 2a over t squared. Then the first one, we need to substitute t and substitute 0. So you know that you bounded t, then substitute 0. Any t lowercase substituted by t uppercase. Then the next thing, subtract it from t. We'll substitute t as 0. So it will be t upper over k omega naught sine k omega naught t uppercase minus t here will be 0, 1 over k omega naught sine k omega naught 0 times 0. Then after that, don't forget the integral. Minus integral from 0 to t. I like to put the constants outside of the integral 1 over k omega naught. Then the integral of sine k omega naught k omega naught t dt. Now let's do some analysis. Basically, the first part here, 0 times anything, 0. Then here, sine k omega naught t. Let's think about it. So, we're going to here, sine k omega naught t. What we know about k, about omega naught, we know omega naught equal 2 pi over t. So it will be as sine of k 2 pi over t times t. T and t cancel each other. This remaining as sine k times 2 pi. K can be any constant, can be k equal 1, k equal 2, etc. So sine of 2 pi is actually 0. Sine of 4 pi will be 0, and etc. So this yields this term to be 0. Sine 2 pi 360 is the same as sine of 0, then it will be 0. Sine 4 pi, the same as 2 pi, the same as 0, which will be 0. So the other term will be 0 as well. Then the remaining thing, which is the integral. The integral, look at inside the sign of this integral. We are making the integral of the sine over two whole period. So imagine that there is a sine, here is 0, here is t. So the integral is the negative area and the positive area will cancel each other. Is this correct? Then this is 0 as well. Then what do you think AK will be? 0. Everything is 0. So the second unknown, done. Okay? Again, just like the complexity of this is the math. Just if you still like struggle with math, please review integration by parts. Then step number 3, which is we need to calculate Vk. Vk, according to the formula, 2 over t, the integral from 0 to t, x of t, sine k omega naught t dt. Then substitutes x of t with its value. So 2 over t, the integral from 0 to t, x of t is actually a over t uppercase times t. Then sine k omega naught t dt. Let's put the constants outside of the integral. Then this yields to be 2a over t squared, the integral from 0 to t sine k omega naught t dt. Now, this integral, how can we do the integration of this one? By parts, integration by parts again. So again, in Fourier series, we will do a lot of integration by parts. Keep this in mind. So t, I'm going to assume it as u. Then sine k omega naught t dt, I'm going to assume it as dt. So we can say u equal t, then the derivative du will be dt. dv equals to sine k omega naught t dt. Then v, which is the integration of the sine, which is negative cosine, and there's a constant, so negative 1 over k omega naught cosine of k omega naught t. And according to the integration by parts, do the products here, the diagonal, we will do the products, and here we will do minus integral. So as a result, we can say that the integration of u dv will be uv minus the integral of v du. Let's do it here. We can say b sub k will be 2a over t squared. Then we have t times u times v, which is t times negative 1 over k omega naught times cosine k omega naught t. Then the part between from 0 to t minus the integral from 0 to t of v du, v here, which is negative 1 over k omega naught times cosine k omega naught t dt. Then let's do the simplification. Before you hear the brackets, fix this brackets like this. Then I can say b sub k equals to 2a over t squared. Then substitute t will be t times 1 over k omega naught times cosine of k omega naught t minus t times minus 0 times negative 1 over k omega naught cosine of 0. Then for this one, there's a negative sign. Negative sign will make it positive. I'll put the constant outside of the integral. So it will be plus the integral from 0 to t, and before the constant, plus 1 over k omega naught from 0 to t, cosine k omega naught t dt. Then close the bigger brackets. Okay, let's see here. This term, 0. Even though cosine 0 is 1, but there's times 0 will be 0. This term is 0. Okay. How about this term? Cosine and around the full period. So if you have this period like this way, then basically you can say the positive area and the negative area cancel each other. Okay. So therefore, this one will be definitely 0, right? The sine or cosine over the full period, the positive side and the negative side will cancel each other. Is this correct? Yes. So this is 0. Then the remaining part or the remaining element, which is cosine k omega naught t. Let's think about what's cosine k omega naught t. Cosine k omega naught t, or in other words, it's cosine of k 2 pi over t times t or in other words, cosine of k 2 pi. What do we know about k? K equal 1, k equal 2, etc. When it is 1, cosine 2 pi. Cosine 2 pi, which is the same as 0, cosine of 0 will be 1. Cosine of 4 pi will be 1 as well. So it's every time will be 1, no matter what's the value k. So as a result, the cosine is 1. Then we can say b sub k will be 2a over t squared, then this integral over is t times 1 over k omega naught times cosine, which is 1, minus 0, then plus the integral, which is 0. Then we can simplify it more. It will be as 2a t and t with t squared, so it will be t here, times k omega naught. Okay? So we will not stop here because we know omega naught equals 2 pi over t. So it will be as 2a over 2k times 2 pi over t. So t and t cancel each other, 2 and 2 cancel each other. This yields to be a over k pi.
Wouldn't it be negative?
I think there will be negative, right? I've already think. So this will be negative here, and the reason because there's a negative sign. So it will be negative, negative. Okay. So as a result, bk equals negative a over k. So let's summarize the parameters. A0 was a over 2. A sub k, it is 0. bk will be negative a over k pi. Now it's time to substitute them in the expression that we did in the beginning, which is this expression. We will substitute them here. Since b is 0, there is no need to, ak is 0, there is no need to write it. So we can say x of t equals to a over 2 plus the sum with k equal 1 up to infinity of negative a over k pi sine of k omega naught t, or we can say 2 pi k over t, 2 pi k over t, then that's it, properly done. Okay, any question? So in summary, that sawtooth signal that we saw, we can represent it with this infinite series. And again, this is useful for us in analyzing some signals, in generating some signals. Then that's how we represent them into terms of sine and cosine. And you will use this again later in communications. If you go to wireless communication classes, so this will be very beneficial for you. We're going to use Fourier series a lot. Then later also you will learn about something called discrete Fourier series, discrete Fourier analysis. This will be more advanced topic. So maybe you can, the next, I think, course related to signals will be DSP, digital signal processing. I think this is grad level, but you will, do more math on Fourier series with that course. Now, if we need to plot this, again, remember when we do the plotting, here is the MATLAB, I think this is the tables, just a quick reminder, then let's go to the MATLAB. This is how each signal is presented, then this is the MATLAB code. So, again, remember that's how many Fourier coefficient that we need to use. So, Fourier coefficient here, I assume we need to plot 4. So of course, the larger number of Fourier coefficients, the higher accuracy of the waveform. So this is how's the sawtooth signal MATLAB code. So you can read it. I think it's easy to understand. Just define A as 2, the period as 1 second. Then this is the how to find A naught and how to find BK. K keep in mind A naughts, you don't need to put it inside the for loop because it is one value, while B, okay, there's a for loop up to n which is number of Fourier coefficients. If you change n to be 10, 20, 40, you can get better accuracy. But the thing which is inside the for loop, it will take more or longer processing time. So the output of it, when you assume 4 Fourier components, it will be like this. Our target is to get a sawtooth. Sawtooth, which is, I can go back here, tell you sawtooth like this. That's what's supposed to be the result. But when we go to the plotting, with Fourier coefficient, it's not 100% correct. I mean, there is a lot of distortion. Then, if we increase it to be 10, it's better. This is better. Way better than that. Then, if we make it more, 40, it's even better. Now we notice something here. And if you zoom it, you will see the difference. You will see that it's not 100% accurate. Again, imagine this when I told you, when I say the example about the pictures or the photo resolutions, last lecture about SD, HD, Full HD. So you can notice the resolution, especially when you do zooming or when you show it in big screens. You can see the difference. This don't have high resolution. This high resolution is better. Then when you use, for example, 1000, it's even much better. Okay, so 1000 was big with this is a big number. So if I'm satisfied with this accuracy, then I define the infinity as 1000. This is the approximate. So again, I can define my answer to be 99.5% as 100. That's enough. Or I can define it as 98, 95. So it depends on what I need, depending on my need. Okay, any question about this example? Okay, now let's go to, keep going for this series, but there is some property that is called symmetry. Symmetry. Property of Fourier series. Fs means Fourier series. So we know there is something called even symmetry, and there is something called odd symmetry. We already discussed this when during the first month of this course. What does even symmetry mean? X of t equals to x of negative t, right? Is this correct? Yes. What does odd symmetry mean? When x of t equal to negative x of negative t. As an example of even symmetry, we have, for example, like this function. This is even symmetry. Odd symmetry, something like this, as an example. Okay? Now also I have a question about sine or cosine. Whenever you have a sine or cosine, is cosine even or odd? Even. Even, correct. So here's the cosine. Which is even. How about the sine? Odd. Odd. So basically, again, when you see x of t equal to negative x of negative t, then this is odd. Then we will assume this is even. Okay? There is a nice feature that we can use if it is even or if it is odd. Likewise, if it is even, we can say bk every time we be 0. If it is odd, we can say AK every time we use it. Okay, so how can I find Fourier series? So Fourier series for even symmetry will be x of t equals a0 plus sum from k equal to 1 up to infinity ak cosine k omega naught t. That's it. While when we do it for even, x of t, I'm sorry, for odd ak will be 0. So x of t will be a naught plus the sum from k equal 1 up to infinity bk sine k omega naught t. So it's just like the term associated with b or with a, ak will be 0 or bk will be 0, depending on if it is even or odd. Then, how to find a naught? We know how to find it. But the thing which is that will make it easier in calculating ak. A sub k will be, we used to know it as it will be 2 over t, the integral from 0 to t, x of t cosine k omega naught t dt. That's what we used to know and calculates ak. But the thing here, if it is even, we can make it as a sub k equal 4 over t, the integral from 0 up to t over 2, x of t cosine k omega naught t dt. What's the difference here? Which is the integral will be now from 0 to t over 2, and we reduce the integral. We will do the integral only for the first half, not the full period. So if you can assume that this is, for example, cosine so we will do the integral, for example, in this part. We will not take the other parts. From 0 to t over 2. Okay? So basically, we will take for first half and multiply by 2. So that's, we will say that 2 times, when we take it from 0, 2 over 2. That's what we did. Integral from 0 to t will be 2 times from 0 over t over 2. So, what's the benefit here? We'll make the integral easier. We'll make the integral easier. Okay? How about odd symmetry? If it is odd, very similar to what we do here, bk will be 2 over t, the integral from 0 to t, x of t sine k omega naught t dt. Then here the period from 0 to t, then here comes 2. If it is odd, we can say b sub k equal 4 over t, the integral from 0 to t over 2, x of t sine k omega naught t dt. So here you can imagine this that you have like sine, then here is from 0 t over 2. We will take only the first half. So as a result, as from 0 to t equal to 2 times the integral from 0 to t over 2. That's what we did. Okay? So if the function is even symmetry, even I think here in odd, I want just to make expression, there will be no a0, a0 a0. So keep in mind, if it is odd, no a's, there will be only b. If it is even, no b's, there will be only a. Okay? In summary, if the signal, if you don't know the signal, is this even or odd, apply the general Fourier series that you know, if you have no idea. If you are not certain, I'm not sure, is it even or odd, or you still have, confused about this, then do the original formula. The general formula that we learned in this lecture or the previous lecture can be applied anytime, no matter if it's even or odd. But we will say, using the symmetrical property of Fourier series, we can make the life easier. So we can skip one step, which is, I don't need to calculate A, B, K. If we say A naught, A, K, B, K, so if we see, for example, this is even symmetry, then neglect B will be erased. And keep in mind the integral you will do for the half cycle, from 0 up to 2 over t, and therefore we can make it times 2, so it will be 4 over t. While, if it is odd, you don't need to calculate A, so it will be B not alone. Okay? So here just the point is, we will use this property to make the problem easier, so we can solve it and can solve the problem with less efforts, less time. That's the point. So odd symmetry, odd A is equal to 0, even B is equal to 0. That's it. You need to calculate A's, you need to calculate B's, and don't forget to say the integral from 0 to t will be 2 times the integral from 0 to over 2, and the same thing. T will be 2 times the integral from 0 to over 2. These two notes summarize everything. Okay, any question? Okay, let's discuss the sawtooth again. So the sawtooth, t, x of t, is this function even? Let's assume here is it even? No. Is it odd? No. So this is neither even. Neither. Neither. No. Okay. Let's think about this. Can we make x of t minus a over 2 subtract by a over 2? Let's think and let's try. If we make a over 2, we will shift it down a little bit. So this yields to be as like this one. So we see this is bounded between a over 2, negative a over 2. Now, is this even or odd or neither? Okay, so is x of t, you can, for example, try observe one point. Like let's observe this point, which is almost this point. So you will see they are the opposites. So it is odd, right? So this is odd. So you can say in this situation, x of t minus a over 2 is odd, and I can assume it as z of t. Then for z of t, since it's odd, a naught will be 0, ak will be 0, then the only thing that you need to do is to calculate bk, right? So you can calculate it. So after doing the calculation, you can remodel this by saying since z of t equal x of t minus a over 2, then as a result, x of t will be z of t plus a over 2. This term is constant. Since it's constant, what's the constant term? A naught. So as a result, we can say in x of t, a naught will be a over 2, ak will be 0, bk, that's the thing that you calculate. like this is a triplet. So this one is neither odd or even, but when we shift it a little bit, we realize it's odd. And odd, all of the A's are zeros. Then when you calculate B, after you calculate B, you can shift it back to the origin. Then that shift is actually a constant. That constant is A0. Okay, does this make sense? This is kind of tricky. Okay, any question about this? Let's go to one of the problems in the textbook. I think problem 5.2. Let me plot the waveform. So here, and let's continue further. Then, this is the magnitude. A equal 10, and here is 0, here is t, and it is equal to 4, here is 2t, which is 8 seconds. Here is time t, and here is negative t, which is negative 4 seconds. Then the magnitude 10, and keep in mind the peak will happen at t over 2, just to make sure that we know that's centered at the bottom here, at the top, which is on the middle cycle at 2 seconds. Now, the question says, the first thing, part A, is it even or odd symmetry? What do you think? Is it even or odd? Even, because x of t and negative x of t is like a mirror. Since it's like a mirror on the x-axis, then this is yes, even. So we can say it is even. Now, part B, find sine, cosine, Fourier series representation. So we need to find the sine or cosine of Fourier series. How to find the Fourier series? We can write a general formula, but let's use the benefits of even. Since it's even, we can say even means all of the A's, all of the B's will be zeros. B's equals to 0. So let's take the advantages. Since it's even, we can say x of t equal a naught plus the integral from k equal 1 up to infinity of a sub k, k or cosine k omega minus t. Because again, bk equal to 0 because it's even. Then let's calculate a naught, let's calculate ak. How to calculate a naught? A naught is the average. So look at this function. What's the average? Here this goes up, then it will go down. Or you can imagine this as we need to find the area. So the area is 1/2 over this rectangular area, which is 1/2 times the base times let me do this. 1 over t, and t equals 0 to t, x of t. Okay? So this is area of triangle. Then it will be as 1 over t, 1/2 of base, which is t, times the height, which is a. Then t and t cancel each other. This yields to be a over 2, and a we know is 10, t over 2. Therefore, as a result, a naught will be 5. Okay? Or you can do the integration, but if you do the integration, you can go from 0 up to 2 over t, as linear go up, then as t as linear go down. So basically, you can denote x of t as a over t over 2 times t when you have 0 to t over 2 by taking the half cycle, this half cycle. Taking the slope, then this is x of t. Now, we need to calculate AK. How to calculate AK? Let's take the benefits or the advantages of the odd symmetry. Since it's symmetrical, it's even symmetrical actually, take the advantages of it. So we can say A of K will be, it used to be 2 over t, from 0 to t, x of t, cosine K, omega naught t, dt. Again, let's take the advantages of even, it will be 4 over t, so integral from 0 to t over 2. That's what we did. X of t cosine k omega naught t dt, and we calculated x of t here. A over t over 2 times t. So it will be 4 over t, then integral from 0 to t over 2, substitute x of t as a divided by t over 2, t cosine k omega naught t dt. Then let's put them in the other side. So this yields to be as, I'll substitute the values, will be 4 over 4, the integral from 0 up to t over 2. A is actually 10 divided by t over 2, 2 over 2. T is 4 over 2. T is 4 over 2. Then times t cosine k omega naught, which is 2 pi times f. I can write omega naught equal 2 pi over t, which is 2 pi over 4. Then it will be pi over 2. Then it will be cosine k pi over 2 times t dt. Then we can simplify 4 over 4, we'll cancel each other, then it will be the integral of, I can put 10 divided by 2 will be 5, so I will put 5 here, the integral from 0, substitute t as 2, it will be from 0 to 2, t cosine of k pi over 2t dt. Yeah, the completion of this is the math. Now, how to calculate this integral? Integration by parts. So we will assume u equal to t, then du will be dt. How about dv equals cosine of k pi over 2 dt, then v will be the integration, which is 1 over k pi over 2 sine k pi over 2 then it will be products minus integral. So it will be as integral from u dv will be u v minus the integral v du. Then let's substitute in. This yields a sub k will be 5. The integral from u v from 0 to 2. UV, which is t times 1 over k pi over 2 times sine k pi over 2t between 0 to t minus 5 because of I product for both, the integral from 0 2, 1 over k pi over 2 sine k pi over 2t. Okay, let's think about it. So here, let's substitute the values. A sub k will be 5 times 2 times 1 over k pi over 2 times sine of 8 pi over 2 minus 0, because will be 0 times t will be 0, so I'm going to keep it as 0. I don't need to over-explain it. Then subtract it from 5. This is the integral. So for the integral, this is the constant 1 over k pi over 2. Then after applying the integral, it will be as another 1 over k pi over 2 times, since the sine, the integral of the sine, negative cosine, so times negative cosine of k pi over 2t, then substitute it from 0 to 2. Somebody can say, we used to say the integral, this one, to be 0. Why this one is not 0? The previous examples, we used to say it is 0. Yes.
Integrating over half a period.
Exactly, because it's half a period. It's like the integral from 0 to t of the sine or cosine is not 0. While integral from 0 to t of sine or cosine is 0 as the constant. Then let's, after doing this, the integration and substitute the values, ak will be as, actually this element will be 0 after doing it. And this is 0, so the final answer will be negative 5 over k pi over 2 squared of cosine k pi minus 1. Then in order to remove the negative, put pi over 2, make a square. A sub k will be 20 over k squared, pi squared, then 1 minus cosine of k pi. So that's a sub k. As a result, we can say as well cosine k pi, when k equal 1, it will be negative 1. When k equal 2, it will be 1. K equal 3, it will be negative 1. So it can be replaced by negative 1 power k. So a sub k will be 20 over k squared, pi squared of 1 minus negative 1 power k. As a result, we can say x of t substitutes a naught, which is 5 plus the sum of k equal 1 to infinity, 20 over k squared, pi squared, k squared, pi squared, 1 minus negative 1 power k, cosine of k, omega naught t. And we can substitute it omega naught t for this value. Then that's overall expression for this question. And we can substitute omega naught as 2 pi over t, which is 2 pi over 4, in other words, pi over 2. So you can say that it can be cosine of k pi over 2t. Replace this by this. Any question? Okay, that's it for today.